We are recording. So we're going to continue talking about fractions today. And I know it's always intimidating to start this section and see that it's called complex fractions because fractions already seem complicated enough without calling them complex. So first off, this word complex just refers to the structure of these fractions. In fact, I think this section, all told, is one of the more reasonable ones in this unit. So if you're not loving fractions, maybe this one will be a little better. So complex fractions, as you can see from the 4 examples that I have at the top of your page, complex fractions simply mean that you have little fractions in the numerator and denominator of your bigger fraction. Okay, so I've given you kind of 4 pretty common examples, and we're going to work with things that look like this. But what I want you to distinguish is what we're going to do is we're going to simplify these. We don't want those little fractions inside the bigger fraction. And I'm going to show you 2 different ways to do it. And it's my opinion that each of the methods is easier for a particular type of problem. So for instance, we're going to talk about the situation where there is a single fraction in the numerator and the denominator and nothing else. And then the other process is when you have more than one thing in the numerator. So in those examples, there are 2 examples of complex fractions that have a single fraction in the numerator and a single fraction in the denominator and nothing else is what I mean by that. I should probably put those words right here, and nothing else. So what I would like you to do, please, is circle the 2 examples in that top that have a single fraction in the top, a single fraction in the bottom, and nothing else. All right, which ones do you hypothesize are just a single fraction in the top and a single fraction in the bottom and nothing else? First, second, third, fourth. Okay, the first, yes. This one right here is a single fraction in the top and a single fraction in the bottom, and there's nothing else. There's nothing added, there's nothing subtracted, that is it. What's the other one that is a single fraction in the top and a single fraction in the bottom? The fourth, yes, this one right here. We've got two little fractions inside the other one. So notice the 2 in the middle. The reason this one doesn't apply is I do have a fraction in the top, but it's +1. Okay, so that excludes it from what I'm looking for. The third one does have a single fraction in the top, but in the bottom, in addition to the fraction, it's 6 minus that fraction. So there's something else. Okay, so when we just have a fraction over a fraction over a fraction, what we're going to do to simplify in these next examples, when we have a single fraction in the numerator and denominator, what we're going to do is we're just going to treat this as division. We are just going to rely on something we already know how to do, or we've already seen how to do it in the first section. We're going to divide the 2 fractions. So for instance, my example right here, I've got x plus 1 over x. That's the first fraction, divided by, meaning that's what this fraction bar means, and then I got x minus 1 over 2x. So my first step is going to be to do this. To remember, when I divide fractions, what's the process? When we had the little division sign between them, what did we do to divide 2 fractions? Well said. Yes, we are going to change the problem to a multiplication problem, and then we flip the second fraction. Okay, so I'm going to take the x plus 1 over x. I'm going to leave it as is. I'm going to change this fraction bar. Remember, fractions just mean division. I'm going to change that division bar into a multiplication. And then I'm going to take the reciprocal of the second fraction. So instead of x minus 1 over 2x, it's going to be 2x over x minus 1. And then as we've done before, I'm going to just go ahead and cancel anything I can. There's one thing that I can cancel between those 2 fractions. What is it? Yeah, the x. I can cancel the x here and the x here. They're gone. And so what I have left in the numerator is the 2 times the x plus 1. You can distribute that if you want, but I don't do any more work than I need to. And then in the denominator, I have x minus 1. And there we go. That is my reduced expression. I've simplified the complex fraction into a single fraction. We okay with that? Any questions? All right, then I'd like you to do the same thing in exercise 1, just to the right. It's basically the same problem, just slightly different numbers. Give it a try. All right, here we go. Let's try this out. So again, it's a single fraction in the numerator. It's a single fraction in the denominator. There's no things added or subtracted. So I'm going to just treat this like a division problem. I'm going to treat this fraction bar right here in the middle like a division. So it's y plus 2 over 5y. That's the top fraction. I'm not changing that at all. Instead of a division bar, I'm going to write a multiplication. And then I'm going to flip the second fraction into 3y over y minus 2. Any questions, comments, or concerns before I finish this up? Again, there's one thing that'll cancel. These y's will. And so I have in the top 3 times y plus 2. And in the bottom, I have 5 times y minus 2. If you have something that's bothering you about that, please let me know. If you feel okay about it, go to exercise 2. Same sort of thing, just to practice one more time. All right, so this one looks like the following. I'm going to keep the top fraction the same. I got the t plus 4 over the 3t squared. Nothing goes on with that. I'm going to change this division bar in the middle into a multiplication. And then I'm going to do the reciprocal of the bottom fraction. So it becomes 9t over 2t plus 1. There's two things that cancel on this one. I can cancel t's like we have on the previous ones. There's variables. So this t goes with one of those. And then what's the other thing I can cancel on this one? Yeah, the 3. 3 goes into 3 one time. 3 goes into 9 3 times. And that's fully reduced. So now in the numerator, I have the 3 that's left over times the t plus 4. And in the denominator, I have the t that's left over times the 2t plus 1. You can distribute both of those if you really feel like you got to, but I don't feel that way, so I'm done with the problem. So in my opinion, anytime you see a single fraction in the top, a single fraction in the bottom, and nothing else, the easiest, most direct, succinct way to do the problem is treat it like division, okay? That begs the question then, okay, Perkster, I believe you, okay? You haven't led me too far astray this semester, but what about situations where I have like this, where I have fractions, but then I also have other things? How do I simplify those? Okay, and so there's another method. Now, this second method would work on these ones as well, but I just think it's a little extra work than you need to do. That's why I don't advise it. So what we're going to do here down in example 2 is I'm going to take this problem and I'm going to clear the fractions in the numerator and denominator. So when I have other things in my fraction, what we're going to do is we are going to clear the fractions in, I didn't plan this out, in the numerator and denominator. And so all the rest of the problems on this sheet just involve doing this. So here's the process, and then we're going to practice it, and then we'll be good to go. So what you're going to do first is you're going to pick the least common denominator of all the little fractions you see. Oops, I wrote it off to the side. There it is. So looking at this, I've got 2. That's the fraction 2 over 1, but just 2. And then I got 1 over y and 3, and then 5 over y. What's the common denominator between the fractions that I have there? Just y. Yeah, that's it. Just y. So what I'm going to do now is I'm going to multiply every term, top and bottom, by y. Okay, so it's going to look like this. I'm going to, on the left, or excuse me, on the top, I'm going to multiply the 2 by y. I'm going to multiply the 1 over y by y. And I'm going to write it as y over 1. So I remember numerator and denominator. In the bottom, I'm going to multiply the 3 by y. And I'm going to multiply the 5 over y by y, which is y over 1. I do the multiplication. If anything reduces, I reduce. And then we'll be done. So here we go. My first term, when I multiply the 2 times the y, what do I have here for the first term? Yeah, not a trick question. Just trying to get you involved there. 2y, perfect. Plus, when I multiply the 1 over y times y over 1, what happens to those y's? They cancel. Thank you very much. And what's left over when I cancel the y's? 1. Perfect. Great. That's my numerator. The denominator. Same thing. I have y times 3. I'll do this one. That's 3y minus, and now I have 5 over y times y over 1. What am I going to have there as my end result? Yeah, the y's cancel, and I have minus 5 right there. Perfect. Done. Nothing reduces. I don't have to factor anything. That'll be later examples. The first couple are just nice and relaxed and simple to get used to the process. We okay with that? All right, then let's do exercise 3. Bring it on. Just to give you a nudge, I'll still give you a little bit more time just in case. What is the least common denominator of all the fractions that you see in that complex fraction? Just x, that's it. Okay, so I'm going to give you another 45 seconds or so in case you didn't see that. Multiply every one of those 4 terms by x. And I don't think you're going to have to reduce or anything. I think it's going to be pretty straightforward on this. All right, so I'm going to multiply everything by x here, so you can follow along with me as you're working and you're grading your stuff. So I've got x times 4. I've got 3 over x times x, which I'm going to write as x over 1. So I remember what's in the numerator, what's in the denominator, and then the same thing in the bottom. So when I do this, the x times 4, you should have gotten 4x. If anybody gets anything different and you don't understand why, please let me know. Okay, then I have minus, and then the 3 over x times the x over 1, the x's cancel, and I have 3. In the denominator, x times 5 is 5x minus, and then the 2 over x over 1, the x's cancel again, and I have 2. Before I move on, any questions, comments, or concerns about doing that? All right, if you can understand the process on those two, the process doesn't change, okay, but there are, things that are a little more complicated, so I don't want to leave you hanging on that. So flip the page. So your next one, exercise 4. Go ahead and simplify that complex fraction, please. Again, I want to give everybody a little nudge in the right direction. Okay, I'm not going to do the problem yet, but let's identify the least common denominator. What's the common denominator of all the fractions in the complex fraction? X and Y. Yes, you need both of them. So X and Y. Now multiply every one of the 4 terms by that. X and Y, both of those things. Everything gets multiplied by the same thing. Does anyone not see why it's X and Y? You good? I've got a Y in the denominator in the top. You see that Y right there? And then there's an X in the denominator in the bottom. And the rule for common denominators is you take one of every factor, and then when there's powers, take the highest power. So I need one of every denominator. I need an X, I need a Y. Okay. And then you're going to take that and multiply all 4 by the X and Y. A common mistake is to say, oh, I'm going to multiply the top by Y and the bottom by X. But you can't multiply by different things. That changes the fraction. Okay. Is that better? Okay. All right, let's see how this first one worked out, and then there's plenty of other opportunities with these different denominators. So I identified, just as I mentioned a moment ago, that the common denominator is xy because you need one of every factor you see. So there's an x here, there's a y here. So I'm going to multiply each one of the terms by xy. The fractions, I'm going to write it xy over 1, just so I remember what's the numerator, what's the denominator. All right, let's see what happens. What's my first term when I multiply by xy? Sure, 5xy. Minus, what's the second term going to be? Yep, the y's cancel. And I'm left with 2x. Everybody see that? Okay, if you can understand that, then there's really nothing else going on in these problems, except on some of the later ones we're going to have to simplify, like just practicing our skill of reducing fractions. That's not going to happen on this one, I don't think, though. My first term in the denominator is going to be 4xy plus, and then what's going to be this last term right here when I clear the fraction? Yep, the x's cancel, and I just have 1y or y. Now you are welcome in the numerator, you can factor that x out if you want. In the denominator, you can factor the y out, but nothing's going to reduce here, so I'm not going to go through the trouble. Okay, I've got all different numbers and everything. Is there a question about that at all? Again, if you can understand that, that's as hard as a complex fraction is going to get. The only other novel thing that's going to occur, I think, in the very next problem is after you do that, you're going to have to reduce the fraction. That's the only other thing that can happen. So go ahead and do that now that I've spoiled the surprise. Exercise 5. Anybody got a question? Want to talk it about? Need me for something? All right, so the common denominator is t times w or w times t. The order is unimportant. I just, Miss Hilliard back in 11th grade always demanded alphabetical order, so I've been classically conditioned to do that. So, but that doesn't matter. Anyone have trouble identifying that as the common denominator? Because I want to make sure we're good with that. Okay, once you've got that, I'm going to multiply each of the terms by tw, which I'm going to write as tw over 1. So when I multiply the first term, tw times 4 over t, what's the end result there? Yep, t's cancel, and I have 4w. Minus, what happens next? The w's cancel, and I have 8t. Denominator, the first term, what happens there? What's left? T's cancel, and I have 12 times w, perfect. And then plus, what happens with the last one? Yep, the w's cancel, and I have 24, and then times 3. Any issues? Okay, please let me know. We got plenty of time today. Okay, so this section is not going to take us the whole time, and it's even shorter because I'm doing the worksheets. I'm noticing that today. So if you have any questions at all, let's sort it out before you leave the class today. Before we finish this problem, though, we're going to harken back to section 6.1, where we always reduce our fractions, and we do that by reducing. So what can I factor out of the numerator of this fraction? 4. And when I factor out the 4, I have w minus 2t. In the denominator, what can I factor out of that? A 12, yep. And when I do that, I have w plus 2t. So the reducing is actually a little disappointing here, but there is one thing that'll reduce. 4 goes into 4 one time, 4 goes into 12 3 times. And so here's my reduced fraction. I have w minus 2t in the top, and then I have 3 times w plus 2t in the bottom. And there's my result. All right, if you need any further exposition about that, please raise your hand. Let me come help you. I'm happy to. In the meantime, exercise 6. If there's anything about exercise 6 you think might be confounding, raise your hand. I'll come help you. All right, common denominator, x, y. You need one of every factor you see. When there's powers, you take the highest power of the factors. Okay, in this case, I'm going to multiply my x times y times each of these. Hopefully you've already done this. And hopefully if you didn't and you don't know why, you're asking me a question. And so in the numerator, here's what happens. On the first term, my x's cancel and I have y times 1 is y plus. Here the y's cancel and I have 1 times x is x. In the bottom, the x's cancel, 1 times y is y again. And then finally the y's cancel and I have x. Nothing reduces there. We are done with that problem. It was just a straightforward clear the fractions. Anybody make a mistake that we need to talk about? All right, then do the next one. Exercise 7, please. All right, so the common denominator on this one is m times n. So I'm going to multiply everything by n. So there we go. There we go. And one more time. There we go. Okay, so same sort of thing. If you're not understanding where this comes from, please let me know. We got the ends cancel here. So this time m times m gives me m squared. We good? And then minus, and then over here the m's cancel, and n times n is n squared. Looks like that's going to be able to factor in a minute. Looks like a difference of squares to me. In the denominator here, the m's cancel, and I have n times 1 or n plus, and then here the n's cancel, and I have 1 times m or m. So if you got that far, you did an amazing job. Just don't forget to go as far as possible with reducing. So we factor. This is a difference of squares. I've got two things that are squared, and there's a subtraction between them. So m minus n, or excuse me, m squared minus n squared. The firsts are going to be m and m. The lasts are going to be n and n plus 1 minus the other. The bottom is n plus m. And I do have a factor that will cancel there because adding, it doesn't matter what order you add things in, it's same thing either way. So in the top, I have m plus n. In the bottom, I have n plus m. And so those two will cancel because they are just the same thing. I'm left with an m minus n. Is that m minus n in the top or the bottom of the fraction? It's in the top, so then I can just write m minus n. Remember, if it's in the bottom, you got to write 1 over. Okay, so you got to notate if it's in the numerator or the denominator. Anything pop up on that problem that you need to ask a question about? All right, then do the next one. Example, or excuse me, exercise 8. So each of the last 3 exercises you're going to do have just something a little bit different that I want to point out to you. So these are great chances for questions if something's not obvious to you. Just because this is the first one we've done like this, I'm just going to give you a little nudge. What's the least common denominator on this particular problem? Yeah, m squared, because I see I have a factor of m. And then remember, you take 1 of every factor, and then you take the highest power. And so I have squared. So I need m squared. And then I need a factor of n. And then again, I have a choice. So you always take the highest power, n squared. So that's going to be your common denominator. 1 of every factor you see, and then the highest power when there's powers. All right, so I'm going to start writing in my m squareds and n squareds here, because I'm going to multiply each of these fractions by m squared times n squared. So m squared, n squared. So lots of little m squareds and n squareds. Perfect. There we go. All right, so I appreciate your help here. The first fraction, when I multiply the 1 over m by m squared, n squared, what is left over? Yeah, this m cancels with 1 of those and leaves me m times n squared. There's my first thing. Everyone catching that? All right, plus. The second fraction, I have 1 over n times m squared, n squared. What happens there? What's left over? This time the n cancels with one of those n's up there. So I have m squared n. Once again, if you're not catching it, let me know. The denominator, the canceling is a little cleaner. I've got 1 over m squared times m squared, n squared. What happens with that? Yeah, the m squareds cancel, and I have just n squared, and then minus. And then the similar thing happens with the second fraction. The n squareds cancel, and I just have m squared. Again, if you got that, you have gotten rid of you've done the new bit. The new bit is getting rid of the little fractions. So we've changed the complex fraction into just a regular old fraction. The rest of this is just review. In the top, what can I factor out of the top? An m and an n, they each have 1 to give. So when I have mn squared, I've factored the m out. I started with 2 n's, I factored 1 out, that leaves me an n, plus m squared n, I started with 2 m's, factored 1 out, that leaves me an m, and then I factored the n out. I don't need to write that down. The denominator is a difference of squares. N squared minus m squared. N squared is n times n. M squared is m times m. And then I do plus 1 minus the other. And it is worth it because now I see that I have a binomial that's in common to the top and the bottom. This n plus n, n plus, oh, that's hard to say when you're trying to do it fast. N plus m, and the n plus m cancel, and the top is mn, the bottom is n minus m. Lots of n's and m's, curvy letters. All right, if you feel good and settled, that's good. If not, raise your hand. I'll come to you. In the meantime, exercise 9 is right next door, so go ahead and go for it. My little hint on exercise 9 is even though there's no fractions in the numerator, the x plus y, you still have to multiply each of those by whatever the common denominator is. Okay, so that's why this problem's on here, is to remind you of that. All right, so I'm going to multiply each thing by x times y. Now I know it's pretty obvious in the bottom, you're going to multiply each of these by xy. Okay, but the reason I've included this problem is don't stop there, because what you've done, if you do stop there, you've changed the fraction. Now you've changed the denominator of the big fraction by this factor. And one of the principles of fractions is you have to always multiply the top and the bottom by the same thing. So for that reason, I have to multiply up here by the x times y as well. Okay, so I multiply every one of my terms by x times y. So the first one gives me x squared y, plus the next one is xy squared. That's my top. The bottom, here the y's cancel, and I have x times 1 is x. And then here the x's cancel, and I have 1 times y, or y. If you got there, you've done it 100% correct. The rest is just to factor a little bit. And so I can take that xy back out. Maybe you saw that. If you're good with your algebra, you might have not even multiplied that through. You just left them separate. But if not, I'm going to factor out the x and the y. When I factor the xy, x squared, I factored one of the x's out. I'm left with an x. I factored the y out. Plus, here I factored the x out. Started with two y's, factored one out, I have y. And then I see, oh yeah, I do have a common factor. This x plus y is in common. And so what I have left is xy. Yeah. In a different order. Yx, sure. Yep. That is totally fine. All right, last thing here, exercise 10, the final one. The reason this is on here is what to do when you have a binomial as your common denominator. It's the same process, just want to make sure we get to go through it together. Just to give you a little nudge, there's only one denominator in my little fractions, and it's x plus 5. So that by extension is going to be the common denominator, x plus 5. There's no other denominators. So one of every factor you see, when there's powers, take the highest power. So that's the only factor I see. So now I'm going to multiply each of the four things by x plus 5. I'm going to do that in just a minute. I'm going to give you another minute or so to wrap up, do any distributing you need to do, hint, hint, and take care of business. And then we'll be just about done. All right, I got a little x plus 5 by each of my four terms. And so here goes. This first one, I've got x plus 5 times 6. This is where, don't forget to distribute. It's really kind of the most common mistake here. Is so x plus 5 times 6. 6 times x is going to be 6x. 6 times the 5 is going to be plus 30. So that is my first thing. And then I've got another plus here. And then here I've got 1 over x plus 5 times x plus 5 over 1. Here the x plus 5s cancel, which is what I wanted. So I'm left with 1. In the denominator, the x plus 5s are going to cancel here. And so that leaves me with 3. And then the other common mistake is just don't forget that that 8 has a negative in front of it. Okay, that's super important. So when I distribute, negative 8 times x is negative 8x, and then negative 8 times 5 is negative 40. My numerator is going to be 6x plus 30 plus 1 is 31. Nothing factors out of that, so there's nothing I can do there. And then in the denominator, I've got negative 8x, and then 3 minus 40 is negative 37. And that's about it.